All right, so now we're going to carry on with section 3, where we will introduce 4 definitions of interest rates. All of them are equivalent to each other in the sense that if we use them to price a security like a bond, they will give us the same results. But all 4 of them have their own purposes as far as pricing other securities in the marketplace. So let's get started on this. So we'll go right back to the beginning and remind ourselves that the term structure of interest rates refers to the relationship between the yields on usually treasury bonds and their maturities. So let me show you a quick example of this. So there's one website where you can find look at the yield curve of the Treasury Department very quickly and easily. I keep forgetting the exact name, but if you type in Treasury Gov yields, you should be able to find it. Here it is. So what we're looking for is the daily Treasury par yield curve rates. And we'll get to that in a bit, what that means. But if you notice, you've got all these different maturities and of course the dates, today being the 28th. And so what this is telling me is that on July 1st, these are all the treasury securities that traded in the marketplace. These numbers you're seeing here are called the yield to maturity, which is the rate that we use to discount the cash flows of bonds to come up with their market prices. What's important about these yields, as opposed to the other yields in the economy, is that treasury securities are considered to be free of credit risk. Okay, in other words, if you buy a bond issued by the U.S. Department of Treasury, you can pretty much count on getting the money that you're owed. All right, because the government can raise taxes, which corporations can't. All right, so in other words, if you're buying a corporate bond, there's always some chance that you're not going to receive all the cash flows you were promised. So Treasury securities are considered to be free of credit risk, or sometimes it's called default risk, because they have other methods they can use besides taxes. Governments have other sources of income, and then they can always raise taxes if they need to. They can sell off assets, like the U.S. government owns a lot of land and other assets, so they can raise the money if they have to pay off the bondholders. Whereas corporations don't have that luxury. It has to come out of their profits. And if there are no profits, then of course, then there's going to be a problem. So the corporate bonds have varying degrees of risk, credit risk. Okay. And of course, this type of risk can be measured with the ratings provided by 2 major providers, Standard & Poor's and Moody's. And so they give ratings to all these different bonds in the marketplace. And so at least the Standard & Poor's scale, it looks like this. So you start with AAA, then you have AA plus, AA, AA minus, plus, A minus, triple B plus, triple B, triple B minus. Then we cut it off here, and these are the investment grade bonds, as they're called. That means they're all relatively safe. And then when we get below that threshold to double B plus, double B minus, B plus, B minus. And then we go down. Wow, when you get down to the C plus plus, C plus territory, you're in some seriously terrible territory, because these are bonds that are really very close to bankruptcy. And they do keep going. I think they go all the way down to D. C plus, C minus, and then I think they stop at E. Then after that, D means that you're already in default. Okay, so these are collectively known as speculative or junk bonds. Now, of course, you might ask yourself, well, why would you ever buy one of these risky bonds? Well, of course, the whole idea here is that a bond's coupon payment or interest payment is very low, where the very safe bonds such as AAA, and it progressively increases as the credit quality increases. So when you buy a really risky bond, you're basically taking a chance that you'll actually receive all the cash flows, because if you do, you'll actually do quite well. For example, suppose that the interest payment or coupon rate, as it's actually the coupon rate for a AAA bond is, let's say, 4%. And then for a plus bond, it's 7%. Okay, in other words, you see it's going down. For a E bond, it's, let's say, 12%. So you see it goes up and up and up. So if you're getting down to this neighborhood, they're offering some really lucrative coupon payments, but with the understanding you may not see all of them. All right, that's the whole point. But there are actually hedge funds that specialize in identifying corporate bonds that are pretty risky with very poor ratings, but they're of the opinion that the rating is a little too low, which means that they can take a chance on buying it and collecting hopefully all the coupon payments and also getting the principal back at the end. If they're right, they can do extremely well that way. And in fact, studies have shown that default of these bonds is actually much lower than you would expect based on these credit ratings. In other words, there's sort of a bias in these ratings towards overstating the risk of the bond, let's say. In other words, there's maybe not so much risk as it appears from looking at these terrible ratings. But anyway, when it comes to the treasury market, we don't really consider credit risk any longer. It's not really a problem. So what's happening here is that these then, as a result, have the lowest yields in the marketplace. All right. So treasuries offer the lowest yields in the market due to their considered to be, whether that's true or not. But I mean, can you imagine what it would take for the government to run out of money? I mean, they can find the money. Okay. They'll do what they have to do. So they offer the treasury lowest yield due to their high credit, high quality, let's call it low credit risk. It's just like with your own individual credit ratings. You have a credit score. And of course, if you're ridiculously high credit score, you're going to pay a very low rate of interest on your credit cards. If you have a terrible credit score, it's going to be the other way around. So it's exactly the same thing here. It's exact same principle. So now, as far as all these different maturities are concerned, by the way, the way they're classified in the market is there's different names associated with these different maturities. The ones that range from 1 month to 1 year are known as treasury bills. Okay. Treasury securities that have a maturity from 2 years to 10 years are known as treasury notes. And then finally, the ones that have maturities between 20 and 30 years are actually known as treasury bonds. Even though technically they're all bonds, it's kind of a strange convention. But if you read an article in the Wall Street Journal, for example, they're going to be very precise about how they refer to these. They won't, make any mistakes here. In other words, for a treasury note, they'll actually call it a treasury note. For a treasury bill, they'll call it a treasury bill, and for a treasury bond, they'll call it that. Now, what's interesting here is that corporate bonds are not are typically issued with a very small number of maturities. I mean, typically it's 10 years, 20 years, and 30 years, although there could be others. But these are normal for corporate bonds. So in other words, they're perceived as being very long-term investment, whereas the treasury market is different. There's different participants in the treasury market, and there'll be some who buy the long-term bonds because they're saving for their retirement. But at the short end, like the treasury bills, who buys those? Well, there's a lot of times when a business enterprise or even a government has surplus funds that they don't have anything to do with, and owning a treasury bill means that you can earn a reasonably good rate of interest, more than you can get in the bank, without having any credit risk, and also being able to sell them at a moment's notice once you need the money. So it's a very popular way for corporations to keep funds that they don't need just yet while they're planning something to do with them. Also, insurance companies invest heavily in these. Pension funds invest in these because they want to make sure they have enough money to cover their liabilities. Not only that, but foreign central banks own a lot of treasury securities. They typically go for treasury bonds. The Central Bank of Japan and China each owns over $1 trillion worth of U.S. treasury bonds because they're such a safe, stable investment. Okay, so it's a great way to keep your funds safe and liquid, meaning you can sell them at a moment's notice. So, but the reason why the treasury market has so many maturities to choose from is because there's a demand for all those different maturities. Whereas with corporate bonds, nobody's interested in a 2-year corporate bond. It doesn't make any sense. It's something that is consumed, it's considered to be a very long-term investment. People don't buy corporate bonds because they mean to sell them in a couple of years. They usually buy them and hold them all the way to the maturity date. So that's one of the main differences between the two markets. So, but here we have all these different maturities to choose from. Now, these numbers, the relationship between these yields and these maturities, that's what we mean by the term structure of interest rates. Is the relationship between yields, treasury securities, and their maturities. Now, you could, in principle, have a term structure for different credit ratings for bonds. You could, for example, have a AAA term structure and a AA, but you don't see that nearly as often. When you hear the words term structure, it's typically understood to mean that you're looking at the treasury market. And then a graph that shows this relationship is known as the yield curve. Okay. Now, throughout history, most of our history, at least going back to the beginning of the 20th century, yield curves typically were upward sloping. But you know what? In recent years, that hasn't always been the case. So if you look at this one very carefully, you'll see that it actually starts to go up, and then it sort of flattens out and it dips down, and then it starts to rise again. So it kind of looks like um, more like that. It's kind of weird. You don't see that very often, but you know, yield curves can have any shape. If you think of the different sections of the yield curve as having different um, supply and demand considerations, different organizations are using different parts of this maturity spectrum. It's almost like these are different markets all patched together. You know what I mean? Like the individuals and the companies that buy 1-year treasury bills are very different, have different objectives than the ones who buy the notes and then the bonds. So it's almost as if there was independent markets. And that's how the behavior can get like this. So the curves shift up and down over time. If the Fed decides to raise rates, the curve will shift up. Well, not necessarily parallel, like you might go something like that. And then all of a sudden down here, of course, that might be what happens after the Fed cuts rates. Okay. So the curve does shift around over time. And at the moment we're waiting for them to do something. I think they're meeting next week, if I'm remembering correctly. I don't think anyone expects any changes until at least the fall. Inflation is pretty low. I think Powell is worried that there's still a lot of uncertainty in the market and that maybe cutting rates now a little premature. The thing is, the Fed is a very conservative organization. Their number one priority is keeping inflation low, which means not letting it get much above 2%. That's their job. That's what they have been set up to do. So if they're concerned that rate cut would cause inflation to start rising, then they're not going to do it because their job is to stop that. Even if it means holding back on the growth of the economy. Right now, they apparently believe that the best thing to do is sit tight. But probably if they have another couple of good months in September or October when they get together again, they might change their minds and say, all right, fine, we got proof that inflation is not coming back. So we can go ahead and cut rates. Anyway, with all that being said, we've got the term structure of interest rates. Now, the term structure, as we're discussing here, refers to the measure called yield to maturity. Okay. And we're going to see that there are actually four equivalent ways of expressing interest rates in the economy. Yields to maturity is really normally reserved for bonds. Okay. Normally, yield to maturity it's kind of awkward for a lot of other purposes. It's normally used only with bonds. The yield to maturity, it's the discount rate used to determine the price of the bond. All right, what's going on there? I think we're just getting very different out here. I better save it. All right, it's being a little cranky tonight. It gets like this sometimes. All right. Yeah. Okay. Um, all right. So now since we have the end, um, the present value of funds cash flows, the sum of these present values is the bus price. That's how it's done. Okay. But for other applications, this is not a very good measure because we'll see what issues it creates. For pricing derivative securities, which is what we're going to focus on in the rest of this class, um, there are other measures of interest rates that are far superior. They have much more convenient properties. And so we want to be able to convert yields from the yield curve into other equivalent measures of interest rates. So, and in such a way that they preserve the term structure of interest rates. So any bond that I price with yields will give me, I'll get the same result if I use the other equivalent measures. All right. So you'll see what all this means when we get to the definitions. These are the four. Okay, let me just copy these. By the way, I do want to mention in passing here that um, the yield to maturity is not exactly the return to the bondholder, but it's close. Um, Yield to maturity of a bond is close. All right, let's get a minute to worry couple. Is close to the actual return earned by the bondholder. So, but the thing is, the yield will be the actual return if, number one, the bond is held to maturity, meaning you don't sell it before the maturity date. And two, if the coupons or interest payments are reinvested at, at the same rate of return as the maturity. All right, now that those are some pretty strong assumptions. Not that a lot of them don't hold bonds to maturity, it's the reinvestment part can be different. So if these assumptions are not met, then the actual rate of return will differ from the yield to maturity. It may not be very much. It won't be exactly the same. Okay. All right. So what are these rates that we're looking at here? Let me copy the list in here so we can understand, where we're going with this. So now the yield curves, the yields are the ones that we will start. That will always be the starting point. Now, the yield is the unique interest rate at which the market price of the bond equals the present value of its expected future cash flows. There's only going to be that one rate. And you can see that in the yield curve, which is, remember, is downward sloping and one to one or monotonically decreasing. That's my yield curve. So because you can see it is monotonically decreasing, that means that there's going to be an inverse. And that means what I can do is one of two things. Given a yield, I can come up with a price. So in other words, the price is a function of the yield, but the yield can be thought of as the inverse function of the price. So they're inverses of each other. Okay. And we know that there must be an inverse because of the fact that the curve is monotonic. All right. Now, what we're going to need to do here, though, up to this point, we've been taking yields and using them to come up with prices. But now we're going to need to do the opposite. We're going to take prices in the market and turn them into yields. Now, unfortunately, it's not that straightforward. Um, in fact, what's interesting here is that there's a result which you may have heard of. It's called Rene Descartes. Let me just double check this. I believe it's Descartes' rule of signs. But anyway, so there's a rule. It may maybe it's not Descartes' rule of signs, but it turns out that when you have a polynomial, actually this is not a polynomial. It's actually because the exponents are not integers, but it turns out there's a very well-known theorem in math that I can't seem to remember the title of, but it tells us if you have five terms or more, then it's not mathematically possible to invert it. I think it's related to Descartes' rule of signs, but anyway, the bottom line is we're not going to be able to do calculate the inverse here directly. What we'll have to do is use numerical methods, okay, to figure out what yield would make sense with this market price. All right, so we'll get to that in a bit, but so we won't be able to solve the formula. Now, luckily, the other measures do not share this shortcoming. They have their own formulas. That will help things a lot. But here we do have some work to do to figure out the yields based on the prices of these bonds. And also, of course, it's not just the price, it's, the time to maturity, the coupons, and all the rest. All right. So, by the way, I don't know if you're aware of it or not, but, with all this AI stuff that's floating around out there actually exists a product, and I'm always the last one to find out about these things, called Math GPT. It's not Chat GPT, it's Math GPT. And it's just like Chat GPT for mathematicians. I say, is there a theorem that shows that a function with five or more terms cannot be inverted? Yeah, no, I must be misremembering this. But anyway, the bottom line is it's doing an inverse would be very difficult, so I have to use numerical methods. But how do you like that? Look at this thing. It does math. Oh my God. So if you're interested, here it is. So you're stuck on a particularly difficult problem. I mean, you could actually get help out of this thing. And it shows you all the steps. It's unbelievable. Wow. Oh, I was fooling around with it and testing it. Um, and it seems to work pretty well. All right. Well, anyway, let's get back to this. So yields come from the treasury curve, and yields are just like it says here. It is a yield is simply the unique rate of interest at which the bond's price matches up with the present value of its future cash flows. Now, we also have the notion of the spot rate. And the spot rate is interesting because the spot rate is actually a yield to maturity, but for a zero coupon bond. So let's go back and review that for a second. A zero coupon bond does not obviously pay any coupons, but instead is sold at a discount from the face value. Oops, the face value, and then redeemed at the full face value. For example, suppose that a bond is issued, a 1 year, let's just keep it simple, issued with a face value of 1,000 and is sold to investors for, let's say, 970. This means that if you buy this bond, you receive a $30 capital gain instead of a coupon. And now that makes things a lot simpler because the spot rate, if you can think this is the yield. Now, what would that be in this case? If you took capital gain over the price that you paid for this thing. Let's see. Oh, hold on a second. Here we go. Yeah, just a quick calculation. Hold on. I need a calculator for this. 30 over 970 is 0.309. 0309. So while this is the yield of this bond, but because it's zero, um, it is also known as the 1 year spot rate. Okay, because that is the actual rate of return you're getting. You don't have to worry about, are you holding it to maturity? Are you reinvesting the coupons because there aren't any? You buy this bond, this is the return you're getting. End of story. So it's a yield, but it's also the actual rate of return you're getting. So this is what you get with zero coupon bonds. And so the name is different. It's called a spot rate. The 1 year spot rate is that 3.09%. And now we can find these spot rates through a process called bootstrapping, which means you're using the information contained in the yield curve. And each maturity can be used to derive the spot rate for the next maturity. Well, let's see. Here's an example. So let's say we go into the treasury market and oh, you know what I wanted to mention here in case I've forgotten. All treasury bills are sold in the market as zero coupon bonds, while treasury notes and bill bonds are sold as coupon bearing bonds. It's normal for very short-term securities to be sold as zero coupons. What would be the point of having coupons when you've got a 3-month treasury bill, for example? Okay, so that's how this happens. All right. Now, here's the data. When your treasury face value, let me just copy this. So I'm going to make a list here. The maturities, they all, yeah, we're typically going to assume that their face value is $1,000. So I don't need a separate column for that. The 1 year treasury has no coupon. The price is $952.38. Now the yield is 5% because if you read it, this is how you formally figured out the yield. 1,000 minus 952.38 over 952.38 is 47.62 over 952.38. And that works out to be Well, what do you know? It's 5% on the dot. Okay. Well, you can write that as 5% if you want. Now, the 2 year is a coupon bearing bond. It has $55 coupons. The face value is 1,000. The yield is 5.5%. Um, Now, by the way, I do want to point out here a very interesting result. If you notice, there's no mention of this bond's price, or I mean the treasury note. It turns out that one of the interesting results in with fixed income markets is that if a bond has the same coupon rate as the yield to maturity price equals the face value. Now here the coupon is 55, but remember the face value is 1,000. So here the coupon rate is 55 over 1,000. Ah, so you see this bond has the same coupon rate as yield, and that implies a price of $1,000. Uh-huh. So it doesn't say that, but it is an implied. Okay, so the price and the face value are the same. Um, Now, what do we do with this information? Well, in the first year, we already know that the yield and actually because this is a zero coupon bond, in the 1 year maturity, the yield and the spot rate are the same. Okay, so the year one spot rate, 1 year spot rate is equal to the 1 year yield to maturity because the 1 year bond is a zero coupon bond. So the first two will match. So actually, you know what I should have probably done? I should have left more room here. Hold on 1 second. I think I'd like to squeeze it all in together if possible. You'll see what I mean in a second. I want to save a space at the end for the spot rate. So that means in this maturity, these two are always going to be the same. Okay. It's the second one that we're interested in. We want to know what the 2 year spot rate is based on the information we have here. So this is the bootstrapping part. We're taking the term structure and using it to derive the different spot rates, even though it's a yield curve, with the understanding that the shortest maturity bond has a yield equal to its spot rate. That's the starting point. The rest falls into place, and you'll see how in a second. All right, here it is. Oh, whoops, I missed this one. There's a 3 year. 6% instead of 5.5. All right, there it is. Okay, great. Here we go. Um, the price Now, F is the face value of the bond. S1, I'll call it ST here to be more gentle. This is the T-year spot rate. Okay, so here, the 1-year bond, remember, is selling at 952.38. So we just need to do a little algebra now. And that's going to give, now you already know what it's going to be. It's 5%, but let's just demonstrate it. And yes, it's 5%. Okay, now I've already filled in that one, but you get the idea. It's right here, 5%. But we already knew in advance that had to be the case because it's a zero. This is always true with a zero coupon bond. After that, it gets a little trickier. Let's see how we price the 2-year bond. Uh-huh. Now remember, the 2-year bond has a coupon. Okay, now the 2-year bond has a price of $1,000. And keep in mind, what we're solving for is S2. So it has a coupon of 55. We already know the spot rate for 1 year is 5%. Coupon plus face value is 10.55. All right. So again, we just need to do a little algebra. 55 over 1.05 is approximately 52.38. So I subtract, of course, the constants from the 52.38 from the left-hand side and the right-hand side. So I end up with 947.62. Now, of course, I'm going to cross multiply. Let's take the square root. And then subtract 1. And that is going to leave me with 5.51. So it's a very small. Yeah, if we take it at another place, it's 5.514. Okay, so I'm going to fill that in up here. Now you can probably see where this is going. To get to the third spot rate, we have to do the following. Yes, this is a 3-year bond, so we got a lot of work ahead of us. 1,000. This one, remember, this one has $60 coupons. So we already know S1, we know S2. The only thing we don't know is S3. Okay, so I'm going to consolidate these constants real fast. $888.96. Again, just a little algebra. Take the cube root of both sides, subtract 1. And that's going to leave us with 6.041, let's say. Okay, or about 6.041. And then we can keep going from there. No matter how many more there are, we can do this in the exact same way. So we've got the yields and the spot rates. Now there's some interesting things going on here. Uh, we're gonna take a look at them real fast. Oh, sorry, those, what am I doing? Those are the spot rates. That was 0551, I think, 14. And then these would have been 5, 5.5, and then 6. All right, now what I'd like you to notice here is that initially they're equal to each other. For 1 year, the yield equals the spot rate. After that, the spot rate is greater than yield, and the spread between them is increasing. So it's not so obvious here, but if you were to take the yield curve from the market, and this is your yield curve, the spot curve will look something like this. They start out at the same point, they rise together, and as the time, as you can see, as the maturities grow, the spot curve is getting further and further above the yield curve. That's what you would expect here. Now, it turns out that if the yield curve is downward sloping, the relationship will look like this. Okay. All right. Well, that's not perfect, but you get the idea. The spot curve suddenly is now everywhere below the yield curve. And then if the yield curve is flat, then you'll get this. They're both the same. Okay. So when the yield curve is sloping up, um, so is the spot curve, but the spot curve is always above. If if the yield curve is falling, the spot curve is everywhere below it. And then when the yield curve is flat, the two are equal to each other. Huh. Now you can convert spot rates into yields, although I would say this is not nearly as important. And maybe, and here's the formula. I think we'll skip over this for now because most of the time you're taking, because the yield curve is what you see in the marketplace, and then you can convert it into the corresponding spot rates. It's rarely necessary to go the other way around. So I think it's more important to go on to something else. So yeah, this is just proving that, yeah, okay. Now, what is the big deal about spot rates? Why are they so useful compared to yields? Well, the spot curve provides unique rate of interest every maturity. With the yield curve, yield is actually an average of several different spot rates. And that reduces its usefulness for pricing different types of securities in the marketplace, especially derivatives when we get there. So yes, so for bonds, this is fine. But for spot rates, no, it doesn't work. So I mean, for derivatives and other things, you must have spot rates. So and again, it's the idea that each spot rate is unique to that maturity period. Um, it's not necessarily the case with the yield curve. So like here's a quick example of this. Let's say we're pricing a bond, a coupon bearing bond with yields. So the R is a constant, if you notice. This R is the 3-year yield to maturity. So here's the part that seems a little strange. We are actually discounting the coupon received in year one with a 3-year yield to maturity. You're discounting the coupon received in year two with a 3-year yield to maturity. Well, that seems very strange. It doesn't seem very consistent. With spot rates, here's how it actually works. All right, so you see what's happening here is that we're discounting the 1 year coupon with a 1 year spot rate. The 2 year um, coupon with a 2 year spot rate, obviously, and the sum of the 3 year coupon at face value with a 3 year spot. So in other words, each one is getting its own unique rate of interest. There's a lot to be said for that. It makes more economic sense, but again, we'll see later on that these rates are needed for derivative securities and other securities. Um, Bonds are just fine with yields, but most other securities are not. Now, this is where it gets really intense. We're going to introduce the concept of a forward rate of interest. And in a nutshell, the forward rate of interest is one that applies in the future. So if I go into a bank, for example, say I need to borrow money for a car for 5 years, they'll say, fine, here, whatever your credit rating is, here's the rate we'll charge you. But what if I went to the bank and said something like this? A customer attempts to borrow money for a car with a 5 year loan that starts here. Oh, now we're getting tricky here. In other words, he says, listen, I'm going to buy a 5 year car next year. Can we negotiate the rate now? So the rate that is being charged on this car loan is known as the 5 year forward rate, 1 year forward. So that's a lot to think about. In other words, with a forward rate, the starting time and maturity must both be specified. So it could potentially be confusing if you're not used to this. Normally, you say 5 year loan, meaning we start right away. But here, it's a 5 year loan, 1 year in the future. So think of it as a 5 year rate, forward rate, 1 year forward. And so these are used extensively in derivatives pricing models, but the calculations are getting a little bit messier here. So that being the case, I think that can probably wait till our next session. And then we'll then also look at the other rate definition, which is discount rates. Those are much, much simpler. Okay, they're very easy. They can be taken directly from either the spot curve or the forward curve. And then we'll show how all four of them are actually giving us the same results by pricing the same bond with all four types of interest rates. And we'll see that they all result in the same price. Okay. In other words, they're all giving us the same information expressed slightly differently. Not unlike having temperatures in Kelvin, Fahrenheit, and Celsius. The numbers are different, but the way you feel is the same in all three cases. All right. So yeah, this seems like a great stopping point. So let's see, how much more do we have to go here? We also have to learn about the notation. The notation can be a little tricky. We have to be careful with that. We're also going to learn some of the relationships between the three definitions and some key properties, especially the forward rates. Yeah, they can be, it gets very intense with the forward rates. And then we're going to price the bond. Now, this is section 3. In section 4, which I'm sure we'll get to next time, forwards and futures. So we're going to finally introduce these derivative securities we've been talking about all this time. Forwards and futures are relatively straightforward, but then options are where we're going to spend the rest of the course. We're going to understand their properties, and then we're going to understand how to price them. Okay, so Anyway, I think we'll stop here. And the next time we get together, we'll finish up this discussion about forward rates of interest, and then we'll move on to derivatives, one of the most exciting topics there is. And they're also very, very quantitative, as you can imagine. So we'll take care of that next time, and I'll see you then.